Hello, everyone. Welcome to another stream, the second workshop of Artela Aspect Use Case Buildathon. Super excited for this hackathon. We met at the same time yesterday to brainstorm different ideas. This hackathon is all about getting new ideas to the table. Something that I'm super excited myself, looking forward to, is that there are no coding requirements for the hackathon. So it's really a brainstorming ground for everyone. We have Mike and Jack with us from Artela today. Welcome back, guys. And today we're going to talk about the execution of the ideas that we spoke yesterday. Mike was kind enough to um, take us through the numerous ideas and a very elaborate presentation yesterday. But today is going to be even more interesting because we're going to see the execution of it. Very excited myself. Jack is going to be the speaker today. Welcome, Jack. Happy to have any opening thoughts from you and then dive into the workshop.
Yeah, okay, I'll start share my screen.
Yeah, perfect.
Okay, here we go. All right, so hello everyone. Today I'm going to show you how to build something with aspect. Yeah, so we'll do a live coding. So today we are going to build a reentrancy protection aspect. So this will be a very simple implementation. So just hope you guys can be inspired a little bit about what can aspect do and how to use aspect. So last year there was an attack happened on curl protocol. Not sure whether any of you guys know it or not. Anyway, I will briefly explain what has happened. So the root cause of this attack was due to an internal bug in the Viper compiler. So Viper is just another language that can be executed in EVM, just like Solidity. So Viper has a built-in reentrancy guard feature, and the victim contractor was utilizing this feature to protect its methods from being re-entered. But somehow this is not working properly. We have written a very simple example to show you the victim what the victim contract looks like. So basically, this contract has two main methods. So add liquidity and remove liquidity. So as you can see from the code, and both of these methods are guarded by the same reentrant log. So theoretically, if this is working properly, so while you are executing this remove liquidity function, you will not be able to call add liquidity at the same time, and vice versa. So, but somehow this is have some issue in the Viper compiler. And I prepared a very simple script to mock this attack, and we can try it. So so the script will basically just deploy the attacker contract and the curl contract, and this attack contract will try to re-enter the remove liquidity to re-enter from the remove liquidity function to the add liquidity function. And as you can see, after the execution of the script, both of the add liquidity and remove liquidity function gets called. So what actually happening is when you are calling this this remove liquidity function from the attacker contract, it will goes back to the sender. So this fallback function will invoke the add liquidity function of the victim contractor. So this is a very simple mockup of the entire attack. And now let me show you how to protect the smart contract from reentrancy attack with aspect. And this can be an extra security check or after incident patch for whatever reason. Yeah, just wanted to show you guys how this this protection works. So yeah, I already prepared, as you can see, that I already prepared a boilerplate for easier demonstration. If you are creating an aspect from the scratch, and you can try with our aspect tool. I will briefly show you how this works. So you can install the our aspect tool with npm, and you can execute uh, this call, and this will automatically install the tool to your system. And please also know that this since I have already installed this tool, so I will not do it again. So I will just try to create a aspect project with this tool. So after you execute this aspect tool init, and you can see that you will get a assembly script project, and this project contains project structure, which includes the aspect files and some useful scripts for you to bind aspect, deploy aspect, and deploy contract and making call to contract. Yeah, so this is pretty much the boilerplate that the aspect tool can create. And now let's go back to our task. So let's build this reentrancy guard aspect. Now let's go to the aspect file. And we can see that the aspect class has implemented an interface. This is called the pre-contract call join point. And what this means is that we want this aspect to be able to be triggered at right before the contract call gets executed. So if you go into our lab, and you can see there's a bunch of other interfaces that you can implement. If you want to intercept the transaction in different stages, and you can implement multiple of these interfaces for your aspect. For example, if I want to, I can also post contract call, JP, yeah, just something like this. So you can implement multiple interfaces here. So for here, since we want to block the transaction execution as soon as possible when we find the duplicate, when we find the reentrancy. So we can just implement the join point right before the contract call is happening. So we are implementing the pre-contract call. So if you are observing this pre-contract call, you can see that this pre-contract call has an input. So this input is will provide you some basic context of this join point. As you can see that you can extract the call information that from the input, which includes call data, index, guess, and from to, and how much value this call is transferring. And also that you can also extract some block information, and such as a block number. Yeah. Let's write some code to prevent this reentrancy from happening. So we can extract the current call method input.call.data from the our call data, and this and we will save this current call method sig for later use. And also that we want to define the non-reenterable methods, which are the methods that we want to guard. We don't want others to reenter from this method. We can use the helper function that we created, and there's a Ethereum namespace just for easier to compute the actual method sig in Solidity. So yeah, so we want to compute the method sig for the add liquidity and also this remove liquidity. So after we have created the method we want to guard, and we need to do some checks. So for here, we just use the ability that the aspect that can observe the entire EVM call stack. Since the aspect can observe the entire EVM call stack, so we will trace through the call stack to see if there's any of the duplicated non-reentranceable methods gets called. So if there is some duplicate methods, and we will block the transaction from executing. And there's also many other ways to implement such functionality. So for here, I will just show you one of the simplest one. So if the non-reentranceable methods includes the current call method, and we will continue to do some more checks. So for here, we can create a call tree query. The call tree query will basically can provide you the entire call stack of the EVM. So we can look into the call stacks and to see whether there's something wrong with the call. So we can query this through our host API. In the host API, we can communicate from the aspect with the underlying host, which is a blockchain. And we can query the call tree here. And this will return you raw bytes of the call tree, so we need to decode it. So the call tree will be protobuf decode. So yeah, we're using protobuf to encode our structs and yeah, so this can be decoded in this way. So we will then look traversing through the call tree to see whether there is any duplicate methods gets called. And but first we need to know what's the parent call index of the current call. So we can get the parent call of the current call by using by looking into the call tree. So this one will be the call index. This will return your parent call, and you can so this one will be your parent index. So while your parent call index greater or equal than 0, so if this value is less than 0, which means that you already reached the top of the call stack, you're at the root call, so which means we should not go beyond this. Otherwise, there will be an out of bound issue. So the current call will be the call tree calls.get and call index. So this way we can retrieve the parent call. Then we need to check whether the parent call is in the okay. Let's do this. Parent call method is equal to Ethereum parse method sig So this in this way we will extract the particle method seek from the call data, and we need to compare that if that non-reentrable contract includes the call method seek, and this will be to make sure that this method seek is not in our list. Otherwise, there is a reentrancy happens. So oops, we got attacked. Then we will continue traversing the tree. So this is basically what's the can protect. What's this is basically some logics we can protect our contract from being re-entered, and we can try this aspect with our with the attack we implemented before. But first we need to build our aspect. So after the build is done, and we can try to. I have also written another script, and this script will do the same thing as the attack script. But in addition to that, it will also deploy this aspect we just written, and bind this aspect with a victim contract, so we can block the re-entering from happening. So let's execute the script. Yeah, so as you can see that the attack call has been reverted from by our aspect, and you can see that previously the execution was succeeded, and both of the two events gets emitted, but now after we bound our aspect with our victim contract and the transaction now being reverted, so the re-entering has been stopped. This is basically all of my demo today, and I really hope you guys can have some ideas about how to create an aspect project and how to develop, build, and deploy it. If you have any other questions about writing an aspect, please feel free to ask in our Telegram or Discord channel. And thanks all for watching today. Yep. Yeah. So this is a very good question, and so I'm missing some details here because the binding is already in our script. So when binding your aspect with your smart contract, the sender must be the owner of the contract. So if you want to bind your, such as bind this aspect to your smart contract, so you need to bind it by yourself. So others won't be able to bind it to your smart contract. So which means if you want to make sure that no malicious malicious activities happens, so you need to make sure so to review the aspect code carefully. Yeah, so kind of you need to auditing this aspect code. Yeah, something like that. Yeah, there's also some more details. So I'll try to explain. So when you are blending your with a smart contract, and your smart contract must have implemented this interface. So the sender of the transaction will be validated if the sender is the contract owner, and then the blending will be success. Otherwise, it will fail. So yeah, is there any other questions?
No, I think that was the only question we have for
Okay.
now. Yeah.
Okay. Thank you guys all for watching this, and I will stop sharing my screen.
Yeah, thanks a lot on that, Jack. I'm just curious if anyone has any questions regarding the execution, regarding what you spoke about today, or anything in general. What would be the best place to reach out to you?
Yep.
Yep. So thank you, Mishika, for hosting us. So the best place for reach out to us is that you can feel free to join our Telegram group by the link in the DoraHack. So when you register as a hacker in the DoraHack platform, and there is the onboarding page, and in the onboarding page, there's a very important one is the Telegram group. So we'll directly provide all the support there, and you can definitely feel free to reach out to us if you have any questions regarding your project. Thank you.
Got it. Thanks a lot, Mike. So yeah, for everyone watching, go to the hackathon, go to the Artela aspect use case buildathon page on DoraHacks.io. When you scroll down to details, you can see all the resources, which includes the website, additional docs, the hacker resources, and the Telegram as well. Thanks a lot, Lynn, for putting that in. But yeah, that should be your go-to place for any question, for maybe connecting with the Artela team, and yeah, dwelling deep on your use case. But yeah, that was it for today's workshop. The hackathon officially ends on 31st of January, which is the end of this month. So yeah, now that we've wrapped up the workshop, I hope that was super helpful for you in putting out what you were already brainstorming, building. And thanks a lot, Jack and Mike, for the time today. Appreciate you guys, and I wish everyone all the best for the hackathon.
Thank you, Mishika.
Thank you.
Good luck, everyone.
Thanks
Good
a
luck.
lot.
See you guys.